Hello and welcome to Mr. Linford's math course. In today's discussion, we're going to be talking about the change of base formula. We're going to start by reminding ourselves about our previous methods for evaluating logarithmic expressions, and then we're going to get into a new technique and a very helpful technique called the change of base formula. Now, in prior methods, we would have an expression like log base 4 of 16, and we would try to find what does this equal. Well, again, this is saying 4 to what power gets you 16. If I rewrote this as an exponential form, we would say 4 to some unknown power gets us 16. So that unknown value must be 2. Log base 4 of 16 should in fact be a 2. Okay, that was easy enough, but problems would occur when we started having quantities that weren't so obviously related. For example, in this situation, if I said log base 4 of 15 gets me some quantity, what I'm saying is 4 to what power gets me 15? Well, that really isn't going to be a whole number, is it? That quantity is not 1, but it's less than 2, because if it was 2, it would be 16. If it was 1, it would be 4. I'm kind of stuck here. This is not something that I'm really able to find. It's going to be some non-integer value. So the way we get around this is with the change of base formula. The change of base formula is going to help us evaluate any type of logarithmic expression. We first have to say we're going to be working with terms a and b, and let them be positive real numbers. So we have a and b are positive real numbers. Don't have either of them be 1. That's important. A and b are neither 1. Okay? A is not equal to 1 and b is not equal to 1. Then, for any positive real number x, again, we're just dealing with positive real numbers here, we have this property. Log base b of x is equal to log base a of x all over log base a of b. What this is saying is that you can turn a logarithmic expression into a division problem. You can have log base x over log base b, log of x over log of b, and you can choose whatever base you want. Whatever a you want. By this I mean if you pick any positive real number other than 1, you can create this situation. How does that help us? Well, let's take a look at this practice problem here. Log base 5 of 10. I'm basically saying 5 to what power gets me 10? Oh boy, well that's going to be difficult to figure out. What I can do here is I can rewrite this to be log base a of 10 over log base a of 5. And a here, I can choose to be any number I want. And you might say to yourself, well, how is that helpful? Well, our calculators actually have log base 10 automatically programmed in. Pretty much most, if not all, calculators on the market now, when you hit the log button, it's log base 10. So we have those programmed in. So I could actually type into my calculator log of 10 and get a number out. It's 1. And then I could also type log of 5 and I could get a number out for that. Now it's going to be a long decimal, 0.69897, blah, blah, blah. So 1 divided by all of that is 1.43068. I'm going to round up. This is the exponent that I was searching for. Well, it's an approximation of the exponent, okay? And I found this by just using this formula. And again, you can make your base whatever number you want. Make it something convenient for you to use. Here, I chose the value 10 because that's what my calculator already had programmed in. But I could also change this around. I could say instead of 10, why don't I use the number e? Why don't I have a base of e? So in this situation, I'm essentially saying to take the natural log ln of the number 10, and I'm saying take ln of the number 5. You have this button on your calculator. If you're working with a scientific or graphing calculator, you have this programmed in. So hit the ln button, ln of 10, and then divide that by ln of 5. You can probably hear me typing on my calculator, and when I do that, I get the exact same answer, the same value. So it doesn't matter what you pick for your base. Choose something convenient. So what I'd like you to do is pause the video and take a look at this second practice problem. You're trying to find 6 to what power gets you 30. Well, go ahead, pause the video, take a couple minutes, and use this change of base formula to help you figure out this quantity. Again, it's going to be a long decimal, so don't expect a whole number, and choose whatever base you want. So go ahead, pause the video, and let's give this a try. All right, well, hopefully you were able to get the same answer as me. I tried it 2 different ways. I first did this where I had the log of base 10, which is already programmed into my calculator in most calculators. And I did log base 10 of 30 divided by log base 10 of 6, and I got roughly 1.8982. I rounded it off to the 4th decimal place. I also tried it where I made log base e. So I used the natural logarithm button. Again, that's going to be on all scientific and graphing calculators. And I did the natural log of 30 over the natural log of 6, and I got the same value. So it doesn't matter what you pick for your base. Just make sure you're sticking in the proper form, and what we can now do is really go and evaluate any logarithmic expression simply using our calculator. Now, if you have any questions about this, or if you want to go over more problems, or you have any comment about the video, please let me know. My email is klinford, that's KLINFORD, @wccnet.edu. And until next time, take care.